Right. Hi, everyone. I'm going to teach you a little bit about experiment management, some tips and tricks to get your experiment management to the next level. That's the idea, at least. Also, I hope to be adding some memes here and there. That would also be great. We're still ClearML after all. So first things first, experiments, like how do we see this? Basically, I don't have to convince any one of you that you need to version your code, right? We hopefully all do this using Git and whatever you want to. But experiments is basically data scientist life, right? So you're changing a whole bunch of stuff just to get like the higher output of your model or the higher accuracy of your model. So you're trying to get to the best result, but it doesn't always fit with the idea of a commit, right? You don't want to commit every single change you do. And also it's missing a lot of important stuff. So you could see an experiment as a single run, a snapshot of your code, but also your parameters, outputs, things that your code produces, like plots or artifacts or model files, for example, but also console logs, right? Or even more, environment details, because in the end, we want to be able to recreate our experiments, right? That's the end goal here. So you also want your environmental details as like Python packages or system packages to be logged as well. This is what basically extracts experiments from our code, and why experiment tracking is such an important part as well, especially for a data scientist. And then there's data. Now, data is a different beast entirely. So the first tip I'm going to give you is to split experiment and data versioning apart, right? Those do not fit together. I'll explain to you why. The idea is that you can include in your experiments or in your single run, you should include a reference to your data version. Definitely do that. But your data is usually too big, too massive to store every single time you run your code, right? So it's difficult to have them in the same idea. And the same goes for with your code, right? You shouldn't keep your data in Git, for example. Also because it requires specific versioning, right? So no one is going to do a rebase on data, right? It makes little sense. So it needs its own versioning system. Basically, you want data. You want your data genealogy, right? So you want to know where everything came from. But it's also just different from code because, yeah, it's not linear, right? So the idea is that you also want it to be accessible, and that's the third part here. So the idea is that if you want it to be accessible, it means two things. So one, you want to be able to share it with other people, right? So if you have colleagues or people that do similar research than you want to be able to share your data. That's one thing. But also you want to be able to programmatically access it. And that basically means that if you're running your experiments remotely, you want to be able to access them and get a local copy of your data to run on them. So you need your data stored somewhere centrally, which ideally is optimized for large file storage. So now that we got that out of the way, so split your experiments and data, the second tip, and this might sound really basic, but it's log everything. And then I just literally mean everything. The reason why I'm bringing this up, because it seems very simple, is because we see in a lot of the cases in real life, people don't do it. And there's several reasons why they don't do it. So for one, we've heard many times, I have to change my code base. So to counter that, if you've been thinking this, you don't really have to. So in a lot of cases, you will find experiment managers like ClearML that do fully automatic logging. So you basically only have to add 2 lines, that's it, 2 lines of code to an existing code base. You don't have to change your practice or how you like to write code. You just add 2 lines and that's it. And it starts tracking everything. So it's then just a back of the mind type of thing. You also have automatic integration with popular tooling. So if you use TensorBoard or Matplotlib, it should just integrate. And you also want to log your environment. Like I said before, this is harder to do DIY if you try to keep track of it yourself. So recreation is still the end goal here, and you have to capture that as well. Another reason that people don't want to track everything is clutter and storage. So apparently, once you dump everything in there, it starts to become a mess, right? So you have a clutter. And what you can do about that is organizing. So you have automatic archiving, for example, that you can set up once and then use. You have leaderboards or sorting. Leaderboards, I mean, you can just set it to the highest accuracy first, and it'll be that. That'll be nice and clean, right? You also have subprojects. So you have projects, subprojects. In ClearML, you can use subprojects to keep track of different phases of your experiments, which also, again, keeps things nice and tidy. And then you have tags and filtering. So never forget that your experiment list, that every single run of your code, is essentially a database. So you can query on it, and then you can basically filter on it as well to just only have the things that you want to see, right? In my case, I never show my reports because it's just ugly, right? And then on the other side, you have storage, right? So the main tip I can give here is make sure you control your large file storage. So your experiments themselves don't really take that much space. Code and output don't really take that much space. But your large file storage does. And those are basically the models or the weight files, right? And you should control that. You should know where that goes, because basically then you can use whatever you want to. And you can use S3 or GCP buckets or on-premise storage if you want to. And those are virtually limitless. And then you can stop thinking about, oh, should I push this? Should I push? I'm really pushing a lot. No, you should push everything because you have it under control and you know where everything is. And then if you follow these practices, you can go from this, which is the ClearML UI, with aborted and failed and everything through each other and drafts and whatnot, to something nice and tidy with tags and names, and that are all completed, and you can just see everything nice and tidy. And there is a third thing. A third reason why people don't always track their stuff, and that is, where is my data stored, right? Specifically, companies that deal with sensitive data, they can't just push their experiments everywhere. But also, if you just want more control over your own data, you just don't want to send your startup ID or your cool experiments to any old SaaS provider, right? And you're right about that. So a good counter to that is if you're an experiment management system that is open source. And so definitely go with one of these, like ClearML as an example. You can set up your own server and you can set up your own agents completely open source on your own machines. So there is really no reason to be afraid to leak sensitive data. And then, so we've covered 2 tips. The third tip is programmatically access your experiments. And this is something that we see way underused in the real world, and should definitely, you should definitely start doing. So the first part here is that experiments lead to your model repository. And I'll tell you why. So the idea is all models are always saved anyway. So every time I run my training, my models are saved. And so then I am essentially building a model repository, because I have a list of all my runs. I also have a list of all my files, all my weight files, right? And then the idea is that I can, for example, use tags to distinguish which of my models are good and which are not good. So for example, I run an experiment, I've been tinkering for a while, this is the best one I've got, so maybe I can just tag it as latest, and then from wherever I'm hosting my, or like I'm running and inferring my, my models, I can just pull the latest one. And you can essentially query your previous tasks as if they were a model repository, which is very, very powerful. And in ClearML, for example, you can do this. For example, you can do this by just 2 lines. That's all you need, right? So you import the task object from ClearML. That's all you have to do. And then you basically go get the task out of a certain project with a certain tag. And if you only say, I want this out of this project, it will take the latest one from that project that has a tag production. And then you just look into the artifacts, find the trained model, and then get a local copy. And once you have that, you can serve the model from that code base, right? So it gets really, really nice to chain these things together, which actually brings me to access to the code, which is essentially automation, right? So experiments are not just your training scripts. They can be pre-processing, post-processing, downloading of data. Everything that is even part of your pipeline can actually be a separate task or a separate experiment, right? And the idea is that this allows for far-reaching automation. So you can chain experiments together using the programmatic access that I was just talking about. You can get the pre-processed features from your pre-processing experiment and use them in your training experiment, right? And now you're building pipelines. The idea is you are building pipelines, but think small scale for now, right? It's similar to caching in a way. And that also allows for different teams to work on specific parts of your pipeline. Now, ClearML also supports pipelines, actual pipelines, but they're basically based on this system. So if you start doing this well, you can get a lot done. So I hope these 3 tips were very valuable for you. I hope I taught you something new. I see that the 10 minutes mark is coming up. So thank you very much for listening. You'll see all the credentials here. Definitely drop by our Slack channel. It's a really cool community over there. So we've recently breached 1,000, so that's really cool. And yeah, try it yourself. It's open source. There's no downside. Thanks you for listening.